Welcome, guys, to another live episode of Baseline Tech Talk Tuesday. I'm Andy Humphrey, Irrigation Technology Consultant for Baseline. We have Chris Wright, VP of Sales for Baseline. And today we are going to be discussing sensors in green infrastructure. Green infrastructure is something that we see more and more of from existing projects and being pulled into new construction, new development projects. And it's something that has a special interest to Baseline because it's where we have a great product market value fit. And it also threads nicely and was one of the reasons that we developed our spec value ID and our project tracking so that we can ensure that when new projects are installed and designed for green infrastructure, that Baseline can assist with that initial programming and configuration to make sure that the design intent is met and the system operates as intended for special use cases like green infrastructure. I'll preface just a little bit that Chris and I are going to have conversation today. It may go all of 30 minutes. It may go a little short. If you have any questions or you want to add to the conversation, you can do so in the chat. Maybe you've seen some existing projects like this. Maybe you have some experience. Maybe you'd like to share something. The floor is open to sort of join the conversation anytime. So Chris, let's get started with green infrastructure.
Very good. Excellent. Let's start the conversation in our usual tone by discussing, who Baseline is, what we do and why we do it. And, in reality, we engineer irrigation solutions using our proprietary two-wire technology and real-time sensor data to enhance system performance, right? And it's relevant to today's topic. And I know that we've, talked about soil moisture sensors several times as of late. And there was even training last week with Dan and Jeff Hume on soil moisture sensors. But, it's occurred to me, the more we talk about sensors, Andy, the more, content we come up with that's certainly relevant in our space and working with contractors or users that are taking advantage of Baseline's technology.
Yeah, it's amazing what you can do once you have access to the data. It's sort of unlimited, and some use cases have a large market opportunity. Others may be, once every 500 projects in terms of the niche configuration. But once you have access to the data, there's so many use cases that you can come up for it.
Definitely. Yep. And it's becoming more and more relevant because, there's more projects that are getting designed and specified with this green infrastructure concept because it's essentially the new urban development mentality where, the green spaces and different natural use cases are being threaded into the urban environment. And we know, working with, top designers across the country, that more and more of those projects that are happening in these city environments are perfect fits for Baseline technology. Mm-hmm. And it also aligns nicely with, mandates that may be in place, requirements in city code to incorporate these green spaces into the urban environment. So I thought it was worth, defining what green infrastructure means and why it's important. So, as mentioned before, it's incorporating natural environments or spaces into these urban concrete jungles that serve purposes other than just the beauty of them or the emotional well-being. There's some pretty specific reasons why they do it. One is to handle stormwater. Another would be storm surges, which aren't necessarily really in our space. Heat stress, biodiversity, food production, air quality, water, and soils, right? Mm-hmm. So we've spoken to many of these things in past episodes of Tech Talk Tuesday or in virtual drop-ins. And, we've got some really good specific use cases today of projects that we've worked on where technology has been specified into it. And really, it's about respecting that specification and protecting that spec, because there is a specific design intent associated with why baseline technology was designed into the project. And we've got to, understand that if we deviate from that, then it could disrupt or derail the overall intent of the project and, be a failure rather than a success.
Yeah. And I think if I might just chime in here for a moment, in the urban environment, as green infrastructure is constructed and built, it's not natural, right? It's a completely constructed, fabricated environment where the real natural environment, plants self-select to the conditions, to the soil, to the location, to the natural moisture, to the sun, right? They naturally select in those areas so they can live without any sort of man-made engineering involved. Plants grow in certain areas because they're designed for those areas. And in an urban environment, we're essentially, constructing the natural environment into the built environment. And so we're using, technology, baseline being one of them, in order to grow those plants, as naturally as they could, but in this sort of fake built environment. And to do that, we're using, technology that is available today that wasn't available 20 years ago.
True. Absolutely. It's a very good point, right? So when we're creating these spaces and perhaps putting plant material into environments that they're not accustomed or native to, right? The fact that we're taking ornamental crops and putting them into an urban environment, that means that there's a significant, living asset value associated with that, right? And it's important that we use technology and the resources that we have available to us to protect that over time and ensure that, it's not a loss because they're not managed correctly, right? And the technology can really help to achieve that. So I've got up on the screen just a, elementary rendering of a green infrastructure urban environment where you're mixing green structure with, urban farming, natural habitats for wildlife, those things that soften the landscape and, serve to deliver on those benefits of a green infrastructure, a green environment, right? Mm-hmm. So we've got involvement in many of these sectors. And I think the other point I wanted to make is that, if you're working on a project that has baseline installed on it, it's very likely, and you may not know it, that there could be a green infrastructure component associated with it.
Exactly. Right? Sometimes it's not clear during the bidding process, why certain components are being used on a project. Commodities might be sort of dealer's choice, designer's choice on something that they just like. As it relates to technology, there's usually always a reason that it's being used. And, we're going to get to this a little bit later in the discussion today, but part of our process is trying to identify the reason why, so that we can document that intent and then help to program and configure the system so that it gets delivered exactly for that specific purpose.
Right. We're oftentimes not just turning solenoids on and off to deliver water through the sprinklers, right? There's a specific intent. And even though the project may not require the full capacity of the technology that we offer, but there's likely, a handful of
right.
capabilities that are specific to the design intent for that project that require baseline to be on the project itself.
Exactly. That's right. And we've all seen, anyone who's worked through distribution, contractors, et cetera, have seen a project specification come out. And what you might see is a baseline 3200 controller, and it says must do all of these 30 things, but really maybe only 5 of them are being used on this project. And so we're going to get to that a little bit later.
Yep, for sure. All right. So, green infrastructure, it's relevant in our space, because we know that a good functioning green infrastructure increases urban resilience and can help to negate some of those climate related events that are harmful, such as landslides, floods, storm surges, and droughts. And droughts a big one in the West this year. A lot of talk regarding lack of water and better use of water for landscape management and managing these different green spaces. We all know that a green infrastructure increases our overall enjoyment of an urban space, right? It's been known since the times when parks departments were developed, right? If you look at Boston Common, for example, right? It was a green space built into the middle of an urban environment so people could get away from, all of the urban harshness and enjoy nature without having to travel out into the country. But now, as you mentioned earlier this morning, Andy, the whole city has potential to become a park by implementing these different green spaces into the different building structures.
Yep.
And then also something to mention is that, green infrastructure is often less expensive than a gray infrastructure or an alternative, i.e. where you're putting down hardscape or concrete or, impermeable surfaces. Those are very, very expensive to construct. And oftentimes, people, they look at a green roof, for example, or a green wall, and they think that, oh, that's too expensive, and it gets value engineered out of the project or gets value engineered to a smaller scale on the project. But oftentimes it's less expensive than an alternative. And we've got to remember that and not think that, we're overspending on either the green infrastructure itself or the technology that goes into it.
Yep. Or the management system, that's in charge of it. The
Correct.
green roof is a great example. I don't think we have anything specific on slides, but I know, Chris, we've talked in the past about the fact that green roofs will slow the stormwater runoff and reduce the stormwater runoff.
Mm-hmm.
And, as a irrigation or green roof manager using sensors, you could control how wet would you like to maintain that soil profile. And it certainly wouldn't make any sense to maintain it, all the way to field capacity, because then you've lost your ability to capture any of that rainwater and slow it as it goes down the drain. And so a soil moisture sensor is a great way to maintain maybe a drier root profile so that you have that availability to capture that rainwater and slow it down.
That's right. Yep. And the added result of slowing that stormwater down, and we'll show an example on one slide, different application or emphasis on the slide, but oftentimes these buildings or these environments, they're next to watersheds, right? And trying to keep the urban toxins, if you will, or pollution at bay rather than having it just run off directly into our different waterways and water holding areas.
Mm-hmm.
All right. So where does baseline fit? Just a few examples of some projects that we've been involved with that have had a very specific purpose in using our technology. And they happen to be green infrastructure type projects. And one that we've talked about before but it's such a cool site, cool project, and incredible design intent is Hudson Yards in New York City. We've talked before about the soil moisture sensors being installed to monitor moisture levels for plant health and growth, but there was also a very specific secondary intent of utilizing the soil moisture sensors, correct?
Yeah, there was. And then, the irrigation consultant, who was Mike Astrom, was asked, I can't recall if it was the architect, the landscape architect and engineer, that it would be awesome if we could also manage and report on the soil temperature at Hudson Yards, because it's built on top of the train station. So they had concerns that there might be heat coming up through that built structure into the landscape. And by adding soil moisture sensors that also have temperature sensors built in, we can report on that temperature as well.
Right. Yep. And you can see here right on the, the display that they have at the building site, they can get temperatures in that under structure rail yard of 150 degrees, which, has a detrimental effect on the root growth of the different plant material that's up on grade and on structure. Mm-hmm. So again, very important aspect of this project, where there was a very specific utilization for our technology. And you mentioned, Andy, there's a controller that's on site that just has soil sensors connected to it, correct?
Right. Yeah, because they wanted more sensors, than where they could handle on one controller.
Yep. So very specific use case and very cool, and a great need to understand why it's being used and why you need to respect the spec and protect the spec, and not look for an alternative technology to just operate the sprinkler system.
Yep.
All right. Another cool one that I worked on a few years ago was a site in Salt Lake City, Utah, called Bingham Junction, and it was the previous site of a smelter, and there was a significant contaminated, soil profile on this building site, and there is a freshwater waterway that runs just alongside one side of the property, and they were very concerned about runoff getting into that fresh water supply and having a negative ecological effect on it. So their options were they could either excavate out up to 4 feet of soil across 100 and something acres and put down a film or a layment, and then backfill soil on top of that to create a demarcation line between good soil and bad soil. Instead, we worked with the EPA and developed a specification for moisture sensors to be used at 3 different depths in that existing soil profile to monitor how much water was leaching through the buildable soil and getting to that demarcation line and potentially, leaking into it. So this spec has 3 different sensors, one at grade, one at mid depth, and one at the bottom depth. And we were creating or are creating start, stop, pause conditions associated with those sensors to control how much irrigation we're putting down, adding to that moisture profile in the soil. So the top sensor is there to start programs based on a lower threshold. The mid sensor is there to monitor moisture at a certain depth and could create a pause condition if necessary. And then the bottom sensor was right on that demarcation line. And when it hit a certain threshold, it stopped all irrigation And then the message was actually sent to the EPA, and they were in communication with the maintenance contractors on site about the amount of water that they were applying to the site, right? Yeah. So again, a very specific use case where our sensors are providing that real-time data to achieve a purpose that is well beyond the normal operational capability of a conventional irrigation timer.
Mm-hmm. And yet at the same time, it still turns the irrigation on and off, right? So we've got all this data collection. We're doing all this, call it high tech, fancy engineered applications, but we're also doing the more regular turn the sprinklers on.
Yeah, for sure. Okay. Another cool project that we've been involved with for some time is a green roof application, the Facebook Green Roof. It's 13 acres and growing of green roof on top of their office structures. And you can see here that with the picture from the roof, it's like a city park. It's not like you're on a roof that's covered with sedum.
Right.
This is a very intensive green roof application, and there are many soil moisture sensors throughout the entire roof. There's 20 connected to this one controller that are monitoring different hydrozones on that roof, protecting the living asset value of the plant material that's up there.
Absolutely. I would imagine that having to replace one of those trees on the rooftop would be very expensive.
Yeah. I mean, you got to crane it up from, the grade level, and the caliper of plant material that they were using is pretty substantial. Mm-hmm. So making sure that they are in their, proper health stage is important, so that they don't have to have replacement costs associated with them, right? And at the same time, this is creating a scenario where it's capturing rain events also. And the building is built right on the shoreline of San Francisco Bay. So they're helping to, defer storm runoff from the building lot into the storm drains and into San Francisco Bay. Mm-hmm. Right. So, but you can see it gives us the moisture as well as the temperature, which was important at the Hudson Yards project as well. But having that capability to measure temperature at the same time is very helpful in helping us understand how to manage the site better.
Turf managers love it.
Right.
A lot of times your standard irrigation contractor isn't always tuned into this because they're not the ones managing the turf health. They're the ones delivering the water, but they're not doing the overseeding, the fertilization, et cetera.
Yeah. So it's kind of cool. We were doing a little, off topic research this morning, looking at, the growing cycle of turf grass in different seasons, and when they're putting on roots and when they're putting on top growth and when they're feeding, and temperature is a very, very important part of that. So I think that warrants a whole other Tech Talk Tuesday episode, but we'll talk about it later. But again, having that real-time data is important in managing a complex site that has high asset value and, has a specific design intent. So with that, let's review again. I think we've gone through this before, but what does the design intent mean, right? What is the purpose for its system and its operation? And how are you as a contractor or an operator supposed to configure that controller to achieve the intent of the system, right? And then is there any kind of documentation that's available or could be provided to, archive and refer to, at the time of configuration in programming, but also over time to make sure that it's operating within the required thresholds to ultimately fulfill that design intent.
Mm-hmm.
Right.
Yeah.
So with that, we've been talking about and socializing more and bringing to our clients the SVID, which is the Spec Vault or Service Value ID, which is that very tool to document all of those things to make sure that the project or the controller site gets programmed correctly, configured correctly, so that it will perform long term.
Yeah.
So
is the system set up and configured to do what the designer intended it to do? And historically, we haven't always known what the intent is of these projects, because we've seen a full specification of everything that Baseline or any other competitor can do, and we haven't known which ones matter for this particular site or this project or this application. And so we, meaning Baseline, are going to be working with our specification community to help and assist them in sort of cutting through all of the noise to, boil it right down to, this is the intent of the irrigation system or the Baseline control system, and here's how we want it set up. And it may not have all of the details, but it will provide the folks at Baseline us to help you as a contractor to set it up according to the original design intent.
Yeah. So we encourage you to, have a conversation with your Baseline representative about the SVID and what that means and how you can engage in that, process with us, so that we can get all the information that's, required to have a successful project long term and fulfill that design intent and make sure that it gets configured correctly, because it's all about having success with that client that owns the property, that owns the irrigation system and all the living assets associated with the landscape, right? And making sure that they get long-term what they paid for.
Yep. And we fully realize we can't just make a product and ship it out the door and call it a day. That's not good enough anymore. We need to be there to assist from the design all the way through the programming and configuration to the best of our ability.
Yep. So we've got a question that came in from Don Gella. On the Bingham Junction site, was the bottom sensor a little above the demarc line? So as the water continued to percolate, it didn't pass the line.
It's a fantastic question.
It is a fantastic question. And obviously he's had a situation with a similar scenario, but the bottom sensor was installed just above the demarc line so that water could pass by it. And then it was set to stop irrigation if the water or the moisture level at that demarc line was higher than acceptable.
Yeah. And there's it's kind of like using upper threshold. If the sensor says, cool, that's enough water, there may be another hour of watering that could have occurred, on top of that. So it says, this is cool, I've had enough, but the rest of that hour hasn't, made its way down yet. So I'm guessing that all the settings were accounting for those situations.
Yeah. And then if there were rain events, if there was a significant effective rainfall event that put a lot of water deep into the soil profile, they may not have been able to irrigate, for quite some time after that. So there was some risk to aesthetic value of the landscape if they were holding too much water right at that demarc line, but that was the design intent of the entire property.
That's a good point, because if that lower sensor maintained a wet profile, it would prevent the irrigation from continuing to run until it dried out enough. Yeah, good point.
Correct. Yeah. Another, unique use case for those different sensors at different depths, seen them used in planters as well, to see how much water is being held at the bottom of planters. versus at the top, root area
Mhm.
of those planters, so that they can manage, the weight of those planters themselves too.
Yeah.
So,
And using it as a start, stop, pause device actually allows you to use multiple sensors to control a program instead of just thinking of it as one sensor per program, which historically that's what you did. When you use it for start, stop, pause, you can say which one of these sensors do we want to start, stop, pause, and it could be multiple sensors at multiple percentages.
yep, for sure. So, and it's that real-time data that makes that possible, right?
Yep, with the proprietary 2-wire communication protocol.
Very cool. All right. Well, we've hit the bottom of the hour already.
Perfect.
So a lot of information shared today. Hopefully it was thought provoking. And again, in speaking with your baseline representative, ask questions that you may have about different use cases or about the SFID. We're always happy to engage, and we want to support you in your efforts as well, so that you can, deliver on your commitments and achievements in your profession as well.
Help take us where no control system has gone before.
Okay, Star Trek. All right. With that, we will leave. Okay. Have an excellent week. Thanks for tuning in. We'll see you again next week. Andy and I will be live from New Orleans at the ASIC conference, the American Society of Irrigation Consultants. So we'll have some fun live content to share with you next week. So same time, same place, same day of the week. We'll see you next week.
We'll see you next week, guys.
All right. Thank you.
Bye.
Bye.